Hey there, Mr. Thompson here with a video maths lesson. Talking about graphing lines using intercepts. So we'll talk about what all that means and then how to do it. We'll look at an example. So here we go. When we are graphing lines, we will be doing so on the coordinate plane, the XY axes. Okay, and we're drawing straight lines, so only dealing with straight lines, no curves or anything like that, nothing that turns around, just nice straight lines, like so. The intercepts, when we talk about intercepts of a line, what we're talking about are the points, like these red dots I've drawn, where the line that we're graphing crosses the axes. So where it crosses the x-axis is the x-intercept, and where it crosses the y-axis is the y-intercept. Okay? Pretty simple, hopefully. So let's look. What we can do sometimes is you might be given the coordinates for the intercepts, and you can just plot them. So I'm just throwing dots on here. There's no scale on my axes here, so I'm just kind of putting things on there. But you might be given a y-intercept that's somewhere, this looks like it's negative, maybe down here -5 or -10, who knows what, something like that. And then an x-intercept of something out here, 8, 9, 10, whatever it may be. And you can just plot those on your x and y axes, and then using your nice straight edge, draw a line between them, put the little arrows on the end, and that's it. You've got your line, which is great if you're given those intercepts. If you're not given coordinates of the intercepts, then things can get a little bit trickier. So we'll talk about how to calculate the intercepts when you're given an equation. Before we jump into that, though, I want you to notice something about the intercepts. Okay, the coordinates of this purple intercept, this y-intercept down here, the x-coordinate is 0. Okay, the y-coordinate, we don't, like I was just putting the dot on there. I don't know what the actual number is. We could give it a scale, make it whatever we want, but I'm just going to use the letter y for now to represent that it's some y value. It could be anywhere up and down the y-axis, right? But there's only one x value that can ever be there for the y-intercept, because it's always going to line, that y-axis always lines up with 0 on the x-axis. Okay, so keep that in mind for a minute. And similarly, the x-intercept always has a 0 for the y-coordinate, because no matter where we are along the x-axis, it's always going to line up with 0 on the y-axis. Okay, so we'll write those two things out, those things that we need to remember. The y-intercept has an x value of 0. The x-intercept has a y value of 0. And that's going to be really important for how to find the intercepts when we're given an equation, because what we can do is just plug in the zeros for either of those coordinates and find the other one. So to calculate intercepts from an equation, we set x equal to 0, and then we solve for y, and that gives us the y-intercept. Then we can set y equal to 0, solve for x, and that gives us the x-intercept. Okay, hopefully that makes sense, but we'll look at an example. So if it's a little fuzzy right now, see if this example helps. All right, so the kind of problems that you will see are, they will say graph the following line or lines or whatever by finding the intercepts. You graph the intercepts and then graph the line. So we have 3x plus 2y equals 6. Okay, so our process is that we replace the x with 0. So I rewrite the equation, but instead of writing x, I put a 0. And I always put them in the brackets, the parentheses, to keep it really clear what's going on here. And of course, 3 times 0 is 0, so that just kind of goes away. Anything plus 0 is the same thing, so we can just get rid of that. So we have 2y equals 6. We divide both sides by 2, and we get y equals 3. So our y-intercept is 3. That's where we're going to put a dot on the y-axis for that intercept. Okay, now similarly, we replace the y with 0, okay, over here in brackets again. 2 times 0 is 0, and we have 3x equals 6, so we divide both sides by 3, and we get x equals 2. So that is our x-intercept. Okay, So now we bring on the x and y axes, the coordinate plane, and this time we're going to need a scale. We need those numbers on there so that we can tell that we've put our dots in the right places, right? Our y-intercept was 3, so up here, 1, 2, 3, we put a little dot there, and I'm using blue. And then we, oh, that went quick, but we put a little dot down here at 2 for the x-intercept, and then we draw the line between them. Draw the line that goes between those 2 points, put nice little arrows at the end, and we're good to go. Okay, that's our line. 3x plus 2y equals 6. That's it. Okay. One more example. All right. 10x minus 8y equals 40. Okay. Same exact process. We replace the x with 0. 10 times 0 is 0. Divide both sides by negative 8. Okay. Negative 8 because we have the minus 8y, so that stays negative when we get rid of the 10 times 0. So we divide by negative 8 and we get negative 5, right? 40 divided by negative 8 is negative 5. That's our y-intercept. And then we replace the y with 0. 8 times 0 is 0, so we divide both sides by 10 and we get x equals 4. That is our x-intercept. So we have our y-intercept down here at negative 5, okay? And we'll do a x-intercept over here at 4, and then we draw the line between them. And that's how it works. Can get a little bit more tricky with harder numbers and stuff like that, but it's the same process every time. If you would like to see any more challenging or interesting or different examples, please feel free to let me know in the comments or send me a message. That's it for now. I will talk to you next time.